Let's get started. So let's solve the homework, which was problem 7 to problem 12. First off, we have problem 7. If the pattern continues, what is the next term? 1, 7, 25, 61, 121. What do you see is an obvious pattern? Honestly, for me, look at the differences. You might find a pattern. So looking gives us, this has 6 difference, 8 difference, 50. Not much a pattern. Then what about we try to look at again? So we want to find a different pattern. Or we could use Newton's sum. What is Newton's sum? Or the Newton's little sums, with then using this gives uh 121. And then you look at the common difference. 1 to 7 is uh 6, 18, 50. Oops, sorry. 41. So 61 minus 25, I'm sorry, is like 31. 34. Right, no, 36, I think. Yeah, it's 36, sorry. And then 61, 121, subtract here 50. No, 60. And then from there, you can subtract one more time again. From there, subtraction gives you 36 minus 60 becomes, it becomes 12, 18, 24. So I gotta move this down for a second. 60, 25 minus 7 is 18, 12, 18, 24, and then this is 6, and then 6, which is constant. Now from there, using the Newton's formula, you can just calculate, and this gives an answer of 211. Because then, it's 60, it's 24, next one's it's 6, so this is going to be 30. Then 60, this is going to be 90. 121 plus 90 gives us 211. Working backwards, definitely. Okay. So you get 211 as the answer by just using Newton's little sum. So answer is 211. Newton's read the pattern. 40.592. This obviously looks like the geometric sequence. So we might as well try making it geometric. Now 9 divided by 2 means the common difference is 9 halves because 40.5 divided by 9 halves gives us 9. So from there, you go divide by 9 halves again, gives you oops, no, I meant 9 halves is equal to 2 divided by x. Multiplying gives us 9x is equal to 4. And x equals 4 9ths. Oh wait, I'm sorry, it's 2 9ths, so it's gonna be 9/4. I'm pretty sure. Let me think again. So 40.5, work it out. Divided by 9 is equal to 9 divided by 2. This is then equal to 2 divided by x. So yeah, so the answer is going to be 4 9s. Because I do not know quite how they got a 9/4 as an answer, but it's actually 4 9s. So let's move on to this one. Find the next term in decimal term in the sequence. 0.5, 0.666, 0.7. Convert it to fractions. 0 over 1, 1 over 2, 2 over 3, 3 over 4. Now comes off, of course, going to be 4 over 5, which is 0.8. Just by noticing a pattern, you can solve many things. What is the 100th letter in ABC, 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 and so on? This repeats every 3 terms. And while if it repeats every 3 terms. Okay, so what does Newton's formula mean? Well, Newton's formula is like a small nth term for finding an nth term. You can look at it in past videos. Basically, uses a difference formula trying to make differences downwards, and then you get the desired result when it's constant, and then you add multiply it by its coefficients. The first differences, second differences, by a binomial coefficient, or n choose r. Okay, anyways, to problem 10, what is the 100th letter in the pattern ABC, 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 so on? Remember about remainders, it repeats in the cycle of 3, which is pretty easy. Then we just want to find the remainder when 100 is divided by 3, which gives 1. So the first, it means we gotta count 1, and that gives us A, so the A is the 100th letter. And it is right. Now, problem 11. This sequence shown was formed by writing the first letter of the alphabet, followed by writing the first 2 letters of the alphabet, and so on. Continuing this pattern, what letter is the 280th? Remember before, we know that the sum of the first n integers, positive integers, is equal to n times n plus 1 divided by 2. Then we want to find when n times n plus 1 is less than or equal to 280. Why? Because we want to approach 280, but not going to go over it. And what follows this is 276, which is equal to 1 plus 23 times 23 divided by 2. It's less than 280. That's enough. So it repeat the 23rd cycle finishes in the 276th letter. So when you start the 277th, that's A. 278, that's B. 279th, that's C. 280th is D. Except the cycles that it gives us, the pattern, we can able to use the sum of the first positive integers, make a bound, and then solve. Alright, so the answer is D. The sequence is formed by writing 1A, 2B, 3Cs, so forth, increasing the number of letters by 1 each time the next letter of the alphabet is written. Same strategy. We're first gonna notice that we're gonna use the sum of the first n positive integers in the example, and we're gonna bound it. So n times n plus 1 divided by 2. So why is that true? Because it gets from 1 to 2 to 3 to 4, basically the nth positive integer cycle. Basically, between 1, 2, 3, 4, 5, 6. So it's like this: 1, 2, 3, and we want to find the number of letters until we reach the letter we want. So, and that's n plus 1 over 2. We want to show that we want to have one that's less than or equal to 200. One of them is, the answer is going to be 19 times 19. Oops. 19 plus 1 divided by 2 is less than 200, and in fact it's going to be 190. And then, so what is the 19th letter of the alphabet? It's A, B, C, D, E, F, G, and then so on. And then you find that the 19th is uh S. So 19th is S. So the last letter in that cycle was S. So the rest can be T. Since there are gonna be 20 T's, it's the 200th letter is one of the T's, so the answer is gonna be T. Let's move on. Example 21. Now the lattice sum is continued for 100 rows. What will be in the third number in the 100th row? I'll let you guys have a try and tell your answers in the chat. All right, let's get started with this question. So basically, how are you supposed to do this question? So first of all, notice that every row has 7 numbers, and the last row is a multiple of 7. So what is the remainder when 100 is divided by 7? So the answer is going to be 14 remainder 2. So 100 divided by 7 is equal to 14 remainder 2. Now that 14 tells us that row right over there, let's say this becomes this row 14, there's blah 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 numbers, and then the last number is 98, and we start a new row. So now, with that in your mind, we can go down and solve this problem. So we want to find 99 times 7 first, because we want to find the last number in the 99th row. Because 99 times 7. Well, 99 times 7 99 times 70 is equal to 63 plus 66 equals 693. And then from 693, we go, and then it's going to be 694 is the first in 100, 695, then 696, first, second, third, last, 99th, last. That's how you're supposed to solve this question. Any questions? Type in chat. Seems like there's none. So let's just get started with this next question. Geometric patterns. An example 22. Referring to this sketch, it seems that 3, 9, 18 are required to make triangular patterns as depicted, respectively. How many matches will be needed to construct a similar figure with a 10 matchstick base? Alright, I'll let you guys have a go on this question. Tell me your answers to chat. The answer is not B. Okay, so like I started now. No, but what we're gonna be using is Newton's little formula. Remembering the setup, let's have the first few terms. The next term is gonna be 30 actually. And then we'll start the subtracting. Keep on subtracting. And then by Newton's formula, there's 10 matches, which means there's it's gonna be the 50th term. So if it's 10 matches, the 50th term. And then from there, we want a sub 50 is equal to 3 times 9 choose 0 plus 6 times 9 choose 1 plus 3 times 9 choose 2. From there, 9 times 8 divided by 2 gives you 36. And 3 times 36 gives us 108. Yeah, it's 108. 6 times 9 choose 1 is equal to 54. Basically, 6 times 9. 3 times 9 is 27. And adding all these up, I mean, 3 times 9 to 0 is actually 3 because 9 to 0 is 1. Adding all these up gives you 165. So you should memorize this one, and this might be really helpful in the upcoming problems. 9 minus 12, we're taking the absolute difference. So like, if it's 9 minus 12, it's actually negative 3. Well, we want to take the positive one. So it's going to be 3. Okay. And this one, well, just looking for a pattern. It's not going to require Newton's little formula, which is kind of rough on people like me, you, and people, some others else. I'll let you guys have a try, and then tell me your answers to the chat. Okay, then I'll give you guys a hint. One hint is the answer is not A, it's not E also. Okay, so let's just get started with this question. This is like you know I don't understand it. Oh, someone got C, and someone put D. Oh, Satoru Gojo got it right. So how are we supposed to solve this? So the pattern was basically the number of in the layers of cube. Layer one, layers of number of cubes. There's gonna be 3 layers of 10. 8 layers is gonna be how many will it take to make 8 layers? So basically, if I were to try to solve this, I just realized it's the sum of the first uh 8 triangular numbers, which is easy to work out by hand. It's 1 plus 3 because it's 3 plus 6 plus 10 plus uh gives you a 15 and then gives you plus 21 plus 28 plus 36. These are the first 8. And you should get the answer. 28 plus 36 is 64. Gives you 36. 16, 4, 20, 52, and then, oops, that's 64. Goes down. Hold up. I'm sorry. I mean, this can't go together. This has to go with this. 100. Adding them up, it gives you 120, which gives C as the answer. That was one way. Another way you could do is just notice the pattern. But they're literally just the same math, it's just different approaches. Now let's move on to problem 20, example 24. By considering the pattern shown, how many non-overlapping triangles would appear in the last figure? Tell your answers to chat, I'll let you have a try on this. If I were to try to do it, I'll try looking for a pattern first. Looking at the number of non-overlapping triangles are there. Okay. Does anyone have answers yet?
Give
Okay.
me
What's your
five
question?
more minutes, please.
Say it again.
Can I have 5 more minutes, please?
Okay. Okay, someone just got it right. It's C. And the reason why is just notice the pattern of digits. So this has one triangle. That one has 1 plus 1 times 3. Next one has 1 plus 1 times 3 plus 3 times 3. So the next one is going to be 1 plus 1 times 3 plus 3 times 3 times 9 times 3 gives you 40. Gives you C. Alright. Basically, it was just a pattern find. Let's try to find a pattern. Now let's go on to the next one. Same thing, it's just finding a pattern. Each time a change occurs, center of 1/4 of every white triangle is shaded. What fractional part of the original triangle would be shaded after 4 changes? Express your answer as a common fraction. So this might use some algebra and geometry. Let you guys have a go on it. Tell me your answers to that. This might be a challenge for some. What you need help with? The answer is A, so let's get started. So basically how you're supposed to do this question. Notice that each time a change occurs, the central one-fourth of every white equalizer triangle is shaded. So now, step one, yeah, it's actually A. Step one is to change, it gives you one-fourth, triangle shaded. Step two, or change to one-fourth times plus 3 times one-fourth squared. Right? It's one-fourth of that one-fourth triangle. And step three is gonna be one-fourth plus 3 times one-fourth squared plus 3 times 3 squared times one-fourth cubed. And then step four is just add another 3 cubed times one-fourth to the fourth. Calculating this gives you 175 divided by 256, or A. Let's move on to problem 26. 36 cannon balls are placed on a flat surface in the shape of a square to form the base of a display behind the cannon. How many additional cannonballs are needed to form a pyramid with the given square base? I'll let you guys have a try this question and tell me your answers to the chat. Okay, so the answer is not B. I'll tell you the answer is going to be less than 60. I'll let you guys have like 2 more minutes and then we're gonna solve that question. No, I think it's a 3D pyramid. It's time I solve this question, and the answer is not C. It's actually A. Okay, so how do we solve this? So basically, the base is containing a 6 by 6 uh, basically 6 by 6 circle. Oops, sorry. I'm sorry. It's a 6 by 6 sphere. 6 by 6. And then we're gonna each layer is gonna have one less. So it's gonna be. Oh, you said A. Okay, okay. Oh, sorry. I thought you meant something else. So PL actually got it right. I'm sorry. So basically, it's a 6 by 6, then a 5 by 5 because it's gonna decrease by one layer because it's like this, and then one section, and then second section, third, fourth. It's a 6 by 6, 5 by 5, 4 by 4. Basically, this almost squares. So it's 36 plus 25 plus 16 plus 9 plus 4 plus 1, which gives 55 plus 36 and it gives 91. Oops. But then you subtract 36 because then you get because they already put 36 cannonballs, which then gives you the answer of total 55. Okay. Now let's go to the next question. So congrats to PO for getting that one right. Now I'll let you guys have a try on this question. Tell me your answers in chat. And we'll I didn't add 4 twice. I'm sorry. I meant this could be 9. This is 9. Okay? 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. 9. So let's go have a try on this question until your answers to chat. Right? Sorry about that. So the shaded area is, I think, should be should be over at the over here. Okay? And it keeps on dividing by 1/3 over here, so on. So it's time I did the question seems like nobody got the answer. So basically how we're supposed to do this and notice that uh basically it's right now the area is gonna be approaching 1/3. So at each stage the area of the shaded triangle is 1/3 of the area of the trapezoidal region not containing the smaller triangle being divided by the next step. Thus, the total area of the shaded triangles come closer and closer to 1/3 of the area triangular region ACG. I think it's B, C. I'm gonna check. Oh, sorry. Basically, it was A, B, C, J, That's H, G, F, E, D, K, L over there. So basically, from there, you know that it goes approaches one over the area of the triangular region ACG, and this is 1/3 times 1/2. That's 1/2 times 12 times 12 times 12 equal to 24. So now it gives us the total answer is A. Now the last question, example 28. A grocer stacks apples in the shape of a square pyramid. The bottom layer is 10 by 10, the top layer is 1 by 1, and the nth layer is n by n. Basically, the sum of squares again, which is just 10 squared plus 9 squared plus 8 squared plus 7 squared plus 6 squared plus 5 squared plus 4 squared plus 3 squared plus 2 squared plus 1 squared. So I'll just tell you that sum right away is basically 385, which means the total answer is going to be 385 or B. It's why is because of the pattern. The nth layer is n by n, and there's 10 layers in total. So basically, another formula is the sum of squares is equal to n times n plus 1 times 2n plus 1 divided by 6. That's the formula for the sum of squares. This is a quick note. It seems like we've reached the end of our class periods. Have a good day, and I'll see you next week. Bye.